Good morning, guys. Happy Friday, April 3rd. Today's lesson, rectangle and square proofs. Hopefully you took a look at today's do now. We'll go through that together first. On the graph below, point A, 3, 4, and segment BC with coordinates B, 4, 3, and C, 2, 1 are graphed. What are the coordinates of B prime and C prime after BC undergoes a dilation centered at A with a scale factor of 2? Okay, so those points are going to kind of expand from point A. Remember, we use slope to move the points to their new position for B prime and C prime. So you count from A to B, which would be down 1, right 1. That would be for a scale factor of 1 to just get to its initial location. You just do that one more time. So it's down 1, right 1 to get to B, down 1, right 1 again. That would be a scale factor of 2. So do that slope movement 2 times. That'll give us B prime. Okay, same thing for from A to C, but the movement is different. So it would be down 1, 2, 3, left 1, and now repeat that movement because it's a scale factor of 2. Down 1, 2, 3, left 1, and you have C prime. Notice that the lines are parallel. Right? A dilation creates parallel segments. Okay, so what choice would that be? Right. B prime looks like 5, 2, and C prime looks like 1, negative 2, choice 1. Alrighty, so let's take a look at today how to prove something's rectangle or a square on the coordinate grid. Remember your steps, plot the triangle or the quadrilateral. Today will be quadrilaterals. Find the slope of each side, find the distances, which is just the length of all the sides with the Pythagorean theorem, and then write an explanation. The explanation is key. So how do we prove a quadrilateral is a rectangle? So guys, with these coordinate geometry proofs, the main thing is think of really the simplest property, the most basic day one property of that quadrilateral. All right, and then we're going to use either slope or length to show that. Okay, so rectangle, the simplest possible property you could think of. Okay, hopefully you're thinking maybe right angles. Okay, show 4 right angles. Day one, maybe 5th or 6th grade property you learned. Show 4 right angles. Now how do we do that on the coordinate grid? Remember, opposite reciprocal slopes. Alrighty, and for a square, the square portion of today is really going to combine what we talked about yesterday for the rhombus, showing 4 equal sides. Okay, and what we just listed right here for the rectangle, we also need to show 4 right angles. So show 4 congruent sides and 4 right angles. Alright, so 4 congruent sides. Remember, we're going to use the Pythagorean theorem. Make a right triangle out of the side length. Pythagorean theorem will get you the 4 equal sides. Okay, and then for the 4 right angles, it's the opposite reciprocal slopes. See above what we just said. Alright, so let's get into how this might look. Alright, I plotted the quadrilateral for us. Okay, it says the vertices of quadrilateral math have coordinates you can see there. Prove that this is a rectangle. So just a rectangle to start. So we're going to show 4 right angles. Rectangle, 4 right angles. Alright, this should be right angle all throughout at each vertex. Alright, we need to show that through slope. Okay, through opposite reciprocal slopes. Alright, so for, let's say, MH, our slope is up 1, 2, 3, 4, 5, 6, right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so your slope of MH is equal to 6 over 10. Remember to simplify your slopes. This would be 3/5 when simplified. Now think about a side length sort of next to that. They call that consecutive sides. So see MH, and then the side length next to that. All right, for example, MA. So MA, if we're going to find the slope of MA, please look at what side length I'm talking about here. So MA shouldn't have the same slope, right? The slope should be the opposite reciprocal. Okay, so if I'm going to go from M to A, it'd be down 1, 2, 3, 4, 5, right, 1, 2, 3, which is negative 5/3. Good. These are opposite reciprocals, right? The fractions are flipped and they're different signs. Okay. Now the slope of AT. So kind of going around the horn here. The slope of AT, which is next to MA, should have, right, an opposite reciprocal slope. So if I'm going to find the slope of AT, it's up 1, 2, 3, 4, 5, 6, and then right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 over 10, which is 3/5. And now our slope of HT, which is next to AT, it's also next to MH, okay, is down 5, right 3, so negative 5/3. All right, so you can see opposite reciprocals again. Now you see same slopes as well if you take a look at the 2 3/5. That's for MH and AT. That's because that's opposite sides. Right, opposite sides are parallel for any parallelogram, rectangle, square, rhombus. Okay, and you see negative 5/3, right? Negative 5/3, negative 5/3. Those are the same slope. That's not our focus right now. Yes, that's present because it is a type of parallelogram, but each consecutive side. Now, consecutive side, that's really my main goal for you to understand what are consecutive sides today. So that's MH and MA. Those are consecutive sides. Okay, they're next to each other. They're kind of like back to back. Those have opposite reciprocal slopes. Okay, one of those slopes is 3/5. Another one of those slopes is negative 5/3. So those are consecutive sides. Okay, now same thing for MA and AT. Those are consecutive sides. Okay, same thing for AT and HT. Those are consecutive sides. They have opposite reciprocal slopes. Okay, HT and MH. Those are consecutive sides. Those have opposite reciprocal slopes. So all around, all the consecutive sides have opposite reciprocal slopes. One of them is 3/5. One of them is negative 5/3 for every combination. Okay, for every single combination of consecutive sides, there's opposite reciprocal slopes, meaning a right angle is formed. And in total, that gives us 4 right angles. So it has to be a rectangle. Okay, so explaining that is kind of a pain, but stick with it here. So quadrilateral math is a rectangle because all the consecutive sides all right, and once again, consecutive sides, what is that? The sides right next to each other. All the consecutive sides have opposite reciprocal slopes. All right, meaning they're perpendicular and form 4 right angles. Okay, I'm just going to add the word because all the pairs of consecutive sides. So there's 4 pairs. All right, math is a rectangle because all the pairs of consecutive sides have opposite reciprocal slopes, meaning they're perpendicular and form 4 right angles. that's the most challenging part today, guys, that explanation. But just think about it, okay? The sides next to each other have opposite reciprocal slopes, means they're perpendicular, and there's a right angle. And that process is happening 4 times. There's 4 combinations of consecutive sides, and really the same situation for each of those. Okay? Now, we'll do a square together, and then you will complete a square on your own. Make sure you check back later in the day for the answer key to see how you did. All right. So the quadrilateral has the vertices you can see there. We're going to prove that this is a square. Now, you need to show 4 right angles, exactly like we just did. And then we have to take it a step further after that. We'll have to show 4 equal sides. So, our slope of AD is up 6, right 4. Remember to simplify. That would be 3 over 2. Our slope of, I'm going to go around the horn now, AB is equal to down 1, 2, 3, 4, right 6, down 4, right 6. If we simplify, that would be negative 2/3. All right. Notice opposite reciprocals. That's good. It's flipped and the sign is different. The slope of BC up 6, right 4, which is 3 over 2. And the slope of DC is down 4, right 6, which simplifies to negative 2/3. All right, so this is good. This and this, right? Those are opposite reciprocals. That's good. And you can see that present for each pair of consecutive sides. Now, with that, we will explain that later on, but let's also, since we have to show it's a square, this work, we need to explain it, but this work shows the 4 right angles. Now, we're also going to have to find that all the sides are congruent through the Pythagorean theorem. So that's where we make a side length. We make a right triangle out of the side length. Okay, so we have a side length of 6 and 4. And we'll set up the Pythagorean theorem. 6 squared plus 4 squared is equal to that side length squared, which is AD squared. Okay, so we'll simplify. 36 and 16 is AD squared. Combine those, that'll make 52 is AD squared. And you get AD is equal to radical 52. Now we have to repeat that. Now, remember I talked about the distance formula in class. You could use the distance formula if you'd like, but using the Pythagorean theorem is, if you do this right, you're basically done, because it's going to be the same setup for every single one of these side lengths. If I make a right triangle for AB, this is now 4 and that's 6, and it's the exact same setup. So it would be 4 squared plus 6 squared is equal to AB squared. So you'll go through solving, same thing. It would be 16 and 36 is equal to AB squared. 52 is now AB squared. And we get AB is equal to radical 52. Seems tedious, but you have to keep going. You have to show for all 4 sides. So for BC, make your right triangle. We have 4 and 6 again. So it'd be 4 squared and 6 squared gives you BC squared. Okay, just for time's sake here with the video, you're going to get again that BC when you're done solving is also radical 52. And the same thing for DC, same exact setup. This is 6 now and that's 4. So 6 squared and 4 squared is equal to TC squared. Solve, simplify, right? And you end up with radical 52. So you get 1, 2, 3, 4 equal sides. Okay? So now, what we did just now, right? 4 equal sides, and then before that, our slopes showed us that each pair of consecutive sides has opposite reciprocal slopes, right? Look at the slope section in green. AD and AB, those are opposite reciprocal slopes. AB and BC, opposite reciprocal slopes. BC and DC, and so on and so forth. Every combination of consecutive sides is opposite reciprocal slopes. Okay, so now explaining this. Just like this, what we did in example 1, however, we also have to include the fact that we showed there's 4 equal sides. All right, so ABCD is a square because it has 4 congruent sides and now essentially it has 4 equal sides, and then exactly what we have here. Because all the pairs of consecutive sides have opposite reciprocal slopes. Meaning they are perpendicular and form 4 right angles. So ABCD is a square because it has 4 congruent sides, and because all the pairs of consecutive sides, the sides next to each other, have opposite reciprocal slopes, meaning they're perpendicular and form 4 right angles. Okay? You might be thinking, can't I just say it's a square because it has 4 equal sides and 4 right angles? Well, not necessarily. Really, the main thing that has to happen is, for those right angles, how do you know? Okay, we showed that because of the opposite reciprocal slopes. We know opposite reciprocal slopes means they're perpendicular. We know perpendicular makes right angles. Okay, so this is a 4-point question on a Regents, no doubt, maybe even a 6, but at least a 4. A lot of work that goes into it, but that just kind of goes back to these steps, why I've been emphasizing these steps every single day. All right, to guarantee yourself points. Okay, get the triangle plotted or the quadrilateral, find the slope of each side, find all the distances. That'll guarantee you at least half credit, and then your explanation from there. Okay, you guys have a great weekend. Just know if you didn't do your Delta Math, you can still submit it tonight by 8 o'clock for 75% credit. All right, try example 3. Check back later in the day for the answer key. Message me and remind the questions. All right, have a great weekend, guys. I'll see you on Monday.